Miss Roston, we can't hear you.
Can you hear me at all now?
Yes, ma'am.
Myrna, are you getting me now too? Okay, so let me start over then so you can hear everything. I did post a review sheet in the announcements in D2L. You have a review sheet, the data set that you need, and an answer key. If you haven't completed your course evaluation, which earns you 5 bonus points, if you will do that, okay, you can still have access to that. It is the link to that evaluation, though, is in your Georgia Highlands email, not in D2L. I'm not responsible for sending those out, so it's sent to your Georgia Highlands email. As far as the final exam goes, the final exam is scheduled for a week from today, which is Monday, December the 12th. It's at 12:30, and it'll be in our usual classroom, which is C160. You will have to use Minitab. You may want to have a handheld calculator and obviously a writing utensil, and you can have one 8.5 by 11 sheet of paper with notes front and back to use. So you can write down any examples that you would like to write down. You can write down, if you want to write down little reminders about the Minitab strokes or what you're supposed to read at a particular time in a problem for Minitab, anything that you want to put on that paper, it can be handwritten or typed. You can write as small as you can read. And the layout of the test itself will follow the layout of the review. The first part of the test is you have to calculate the descriptive statistics for, in this case, 3 different variables. I will give you those data sets for the final exam. You will have to use your fingers to type them into Minitab and calculate the descriptive statistics, which we learned how to do in Module 2. The second part of the test focuses on hypothesis testing. Okay, because hypothesis testing encompasses the probability stuff that we talked about, and then of course calculating test statistics and that sort of thing. So if you'll notice, I'll walk through this. The first scenario is a 1 mean T as in tiger test. Then you have a chi-squared goodness of fit test. You have correlation and regression. And you have an Anova. I did make a comment. I went back and added it when I looked at this morning. You need to omit questions 24, 25, 26, and 27. We did not cover or discuss residuals, and I just forgot to take them off in all of the distraction that happened over the weekend. So you can omit questions 24, 25, 26, and 27. Now, I do not know whether any of you have looked at this document and have specific questions, but I can begin at that point to see if you have specific questions about the document, or if not, I can do general questions or otherwise, whatever you guys need. So do you have specific questions either from the course content, from even your Module 4 exam, or the review sheet? Okay, do I need to review how to calculate the descriptive statistics? It's been a while since we've done that. That's part 1. And you've got to be able to calculate those statistics because you're going to need them as you work through the other problems. You may unmute and speak. Okay, Nick says yes. Okay, so for the actual exam, I will have a printed copy of the data set. You will use your fingers and the keyboard to type the data in. This afternoon, I have copied it. It was given to you, and I think I closed it. Hold on just a second. In an Excel format. And so I took that Excel format and I copied it. If you put your mouse in the corner and click, it highlights the whole document. And I can copy. And then I can go into Minitab and paste. But now for the test itself, you have to type it in. So if I want or need to calculate the descriptive statistics for any of those 3 variables, here are the keystrokes. Stat, basic statistics, display descriptive statistics. I'm going to do age. And then I have to tell Minitab, I use the little button, the widget button down here that says statistics, to tell Minitab all of the statistics that I want to calculate. But I don't have to memorize the list because the list is on my document. Okay. So you can read through here. You want sample size, sample mean, sample standard deviation. Okay, you can read down through the list to see all the things that you want to calculate. I've done it so long, I know what they are. Okay, so you need the sample mean, the sample standard deviation, the sample variance, first quartile, median, third quartile, interquartile range, mode, minimum, maximum, and the N total. You want to know how many you have. That's your sample size. Let me get my tablet over here where I can write on it. Okay, so once you tell it all the things you want it to calculate, you're going to click OK. And then I click OK again. And all of my results come up in that window. And I'm going to actually copy it over here to this document so we can look at it. Okay, so then I can start kind of filling in the blanks. Okay, Minitab has given me all of my answers, and assuming that I put the data in correctly, it's going to give me the right answers. Okay, so I had 22 data values. My mean for the age was 25.27. The standard deviation is 8.66. The variance is 75.06. The minimum was 19. Q1 is 19.75. The median was 22. I'm just copying what I got from Minitab. Q3 is 27.25. The maximum was 57. The range was 38. The IQR is 7.5. Oops, didn't ask me for IQR. The mode, it looks like I had two different values. My mode was 19 and 22. It is okay to have two modes. Remember, we've talked about how that you can have two. Nick, you asked to see that. Do you need me to do it again with one of the other variables, or are you okay? Okay. Nick says he's good. Does anybody else need to see it with a different variable? Okay, does anybody need to see the one mean t-test? Now, let me remind you, I know that this is a one mean t-test because I do not know the population standard deviation. Hopefully you can see the nice bold red print that says the population standard deviation is unknown. And so I know that I need to do the t-test. It is a mean. One of the ways I know it's the mean is it does talk about average, which is a synonym for mean. Do you need to see it worked all the way through? Y'all are welcome to unmute. The biggest issue that I remember related to the one mean and the one mean Z and T is that, okay, Kayla and Nick are saying yes. So let me see if I can work this the rest of the way through. It says conduct a hypothesis test to test the claim. So there should be absolutely no doubt what your claim is, because it clearly says test the claim that the average age of GHC students is greater than or equal to 24 using a 0.05 level of significance. The population standard deviation is unknown. Should the findings of the class survey support the belief, and it says hint, you ran the analysis above. Okay, so the first thing you have to do in any hypothesis test is state the hypotheses. So you were clearly given the hypotheses. It's in, it's in quotes and it is italicized. And I see the phrase greater than or equal, which should make you think of the math symbol greater than or equal to. Because it contains equal, this statement is your null hypothesis, because the null hypothesis must always and forever contain equal in some form. So we have that the mean is greater than or equal to 24. And I'm just going to make a note out here to the side that that's the given. The alternative will be the exact opposite of the null. The exact opposite of greater than or equal to will be less than. So I have that the mean is less than 24 as my alternative. If you struggle to know which symbol is which, remember that I posted in the announcements, and let me scroll back down, some key words for hypothesis testing. Now, this list on that announcement is not totally comprehensive. That is not all the phrases that you could use, but they are the more commonly used ones, so that may help you out. But again, you need to remember that the null must always and forever contain equal in some form. Step 2 is to identify the information that you need. Mu is your population mean, which comes from the hypothesis and is 24. You may say, well, Ms. Ralston, it didn't give me X bar or S or N. But if you'll remember at the end of the question, it says, you ran the analysis above. So right up here in this table, I had you find the sample mean, the sample standard deviation, and the sample size. So you're using the results that you found when you ran the descriptive statistics. So my sample mean is 25.27. My sample size was 22. And my standard deviation was 8.66. Everything I need was given to me, or I've calculated it. The level of significance was given in the problem. It's right after the claim, using a 0.05 level of significance. Then it asks, is it a left tail, right tail, or two tail? Remember, we make that determination by looking at the symbol in H sub A, which is the alternative. The alternative has the less than symbol. The less than symbol points to the left. So this is a left tail test. Then I need the test statistic and the p-value, which we find in Minitab. So I'm going over to Minitab. We do stat, basic statistics, one sample T. I have summarized data. My sample size was 22. My sample mean was 25.27. 27. Do I remember that right? Yep. My standard deviation was 8.66. We're conducting a hypothesis test. My hypothesized mean was 24. We're doing a 95% confidence, and my hypothesized mean was less than. We click OK 2 times, and Minitab calculates the t value and the p value that we need. Okay, so these results, which come from Minitab, are going to help me answer questions 5 and 6. My test statistic, it even says T, is 0.69. That comes directly from Minitab. And the p-value is 0.750, which also comes directly from Minitab. 0.05 is your significance level. That's alpha. 0.05 alpha is your level of significance, not the confidence level. Minitab always asks for the confidence level. The confidence level, to find it, is 1 minus the level of significance, which would be 1 minus 0.05, which is 0.95, written as a percentage is 95%. Confidence levels are always expressed as percentages. Level of significance is always expressed as a decimal. So then we're at the stage where we need to make a decision. We have to compare the p-value to alpha. So my p-value from Minitab is 0.750. My level of significance from the problem is 0.05. You compare that digit for digit. First digit after the decimal for the p-value is a 7. The first digit after the decimal for the level of significance is a 0. 7 is greater than 0, so p is greater than alpha. Whenever p is greater than alpha, we fail to reject the null. That guideline has been the same since we started hypothesis testing. Whenever p is greater than alpha, you always and forever fail to reject the null. So, thinking about what that means, if I go back to my hypotheses and I fail to reject the null, that means the null is true and the alternative is false. The conclusion is always written in terms of the true statement. Okay, and so my statement was the average age of GHC students is greater than or equal to 24. Your conclusion always includes your level of significance. So we would say at the 0.05 level of significance, the average age of GHC students is greater than or equal to 24. Now, guys, that process has not changed. That is the same process that we have used for every hypothesis test that we conduct. You state the hypotheses, identify the players, calculate your test statistic and its p-value, make a decision, and write a conclusion. The process has not changed. What has changed throughout the semester is which test statistic you are calculating. Questions on that particular scenario or that particular hypothesis test? All right, the second scenario or the second set of questions is related to a chi-square goodness of fit. You hopefully can recognize it as a chi-square goodness of fit because it says below are the observed exam 1 grades, okay, and you're given the letters. Now they define those letters as numbers, but you have letters. So you have the letters are qualitative data. The only test that we discussed in this class where you use qualitative data is chi-square goodness of fit. Okay, do you need to see this problem worked out? All right, I'm gonna skip number 9 for just a minute because Minitab is gonna do that work for me and calculate the expected value. So I'm gonna skip number 9 and go to our first step in a hypothesis test, which is to state the hypotheses. So if I read this question, it says below are the observed exam 1 grades for all math 2200 classes. Ms. Ralston believes that each grade category has the same proportion. The significance level is 0.05, and then it says fill in the table. Okay, so remember, we look for those words like believe, think, conclude. So this statement, this sentence, that Ms. Ralston believes each category has the same proportion is my hypothesis. Again, it uses the word same. I would anticipate the word same should make you think equal, okay, which means this statement is the null because the null hypothesis always and forever must contain the word equal. So you can actually use that statement. Each grade category has the same proportion, which again implies that they're equal. The null hypothesis must always and forever contain equal. Some folks forgot that on exam 4. The alternative has to be the exact opposite, which means it has to imply not equal. So I can add a few words here and make this statement be not equal. Okay, each grade category does not have the same proportion. Okay, I added 2 words and got it. Now, Minitab is going to calculate the expected values for me. Minitab will calculate the degrees of freedom, my test statistic, and the corresponding p-value. Minitab is going to do all of the work. Okay, I do have to enter the data, so let me scribble the data down. Let me find a little piece of scratch paper here on my desk at home. Okay, so we have A, there are 25, B is 35, C is 20, D is 6, and F is 4. Okay, so I'm going over to Minitab. Oops, that's not Minitab. And I'm going to go over to column 5 because I already have stuff in 1, 2, and 3. And I need to put the grade, okay, which is either an A, a B, a C, a D, or an F. And then I'm going to put the observed counts. Okay, so there were 25 A's, 35 B's, 20 C's, 6 D's, and 4 F's. So I basically took the information off of the paper and I've entered it into Minitab. And now I'm going to calculate the chi-square. Stat tables chi-square goodness of fit test 1 variable. My observed counts are in column 6. My category names are in column 5. And in this problem, we are doing equal proportions. So I click or leave the box next to equal proportions marked. I click OK. And Minitab does all the work. Now, initially, here under observed and expected counts, I'm going to copy this. Well, come on, mouse. That gives me what I need to fill in this table. And I'm trying to get my mouse go where I want it to go, but it's not cooperating. Okay, so then we can paste that in there. Okay, it pasted above it, but hopefully you can see it. Okay, so I now know that my expected for each category from that table is 18. And it should be the same for every one of the levels or grades because we said they were equal. So it should be the same for all of them. In that same result, I get my chi-square test. And in my chi-square test, I get my degrees of freedom, I get chi-square, and I get the p-value. Minitab does all of the work. So my degrees of freedom is 4. My test statistic for chi-square is 37.8889, and my p-value is 0. Then I proceed as I always do, and I need to make a decision. I make a decision by comparing the p-value to the level of significance. And the level of significance was given in the problem as 0.05. So I have 0, which is the p-value from Minitab, compared to my level of significance, which is 0.05. Compare it digit for digit. 0 compared to 0, 0 compared to 5. 0 is less than 5, so P is less than or equal to the level of significance. Whenever the p-value is less than or equal to the level of significance, you reject the null every time, all the time. Okay, so again, thinking about what that means. If I reject the null is false and the alternative is true. So in this case, my belief that each grade category has the same proportion is wrong or incorrect. It's false. So based on the evidence, each grade category does not have the same proportion. And so we would write our conclusion, being sure to include the level of significance. At the 0.05 level of significance, each grade category does not have the same proportion. Questions? All right, the third scenario is correlation and regression. Again, hopefully you should be able to recognize it as correlation and regression, because correlation is and regression is the only test that we talked about where you have two variables at the same time, where you have two variables that are paired together. Okay, now you just had the test on this, so do you need to see this question worked through? I do want to point out one of the biggest questions, or one of the biggest errors that I saw on the test related to correlation and regression was identifying the p-value. And a student pointed out that there is two different places where the p-value occurs. when you look at the printout. And so that may be confusing to some of you. So let me see if I can, without having to work the whole problem, make sure that you're reading the correct information from Minitab. But I'll carry this data over. I'm writing it down, so hold on. Okay, so again, in this case, you would have, and I'm going to get a new worksheet, so I have a clean sheet of paper. And I would put in the number of stories, which is X, and the height in feet of the building is Y. Okay, again, remember, typically your left-hand column is your X and the right-hand column is your Y. And you will have to enter the data just like you've done on your homeworks for the test. Okay, so to get the p-value when you're conducting the hypothesis test, you go stat, regression, regression, fit regression model. The response is always the Y. The continuous predictor is X. And those results really give you three things that you need. It gives you the regression equation, it gives you R squared, and it gives you the p-value. But the p-value that you need is down under the header analysis of variance. A student pointed out to me this morning that you also have p-values up here under the header coefficients. That is not the right one to read. You need the one under the header analysis of variance. So I'm going to copy this over here. So when you're looking for this p-value here under, when you're doing your hypothesis test, you want the one under the header analysis of variance. So for this problem, that p-value would be 0.012. The other issue that kept popping up with the regression is most of you understand that the null hypothesis is rho equals 0 and the alternative is rho does not equal 0. But you are misinterpreting it when you get to the end. If I compare the p-value to alpha 0.012 compared to 0.05, zero to 0, 1 to 5. 1 is less than 5, so p is less than or equal to the level of significance, which means we're going to reject the null. Okay, but guys, if you reject the null, that means the null is false and the alternative is true. And I have been writing out what those two statements mean when you look at them. To say that rho does not equal 0 means there is a correlation and R is statistically significant. Many of you, and I don't know if it was any of you because I looked at so many different papers, But a lot of students are confusing this because they're thinking that because rho does not equal 0, that means there's not a correlation, because that is the wrong interpretation. Remember that your R value is between -1 and +1. And if that value is near 0, that means visually you've got a graph that either is not linear or it's just a bunch of random points. And so if it's not 0, it means I'm somewhere out here around 1 or -1. And so I do have a correlation. It is backwards to what your brain might be telling you. Okay. So if I reject the null, I have to say, yes, R is statistically significant, and yes, there is a linear correlation between the number of stories and the height of the building. Guys, it always goes this way. If you reject the null, you've got to say, yes, R is statistically significant, and yes, there is a linear correlation. Now, on the flip side of that, if you had said you failed to reject the null, then you would have to say, no, R is not statistically significant, and no, there's not a linear correlation. Okay, so that's one of the big mistakes that I kept seeing on module exam 4. And again, I don't know if it was any of you, but that seems to be where a mistake is coming in. Questions? All right, again, remember to omit questions 24, 25, 26, and 27. The last scenario has to do with an Anova. And again, hopefully you can recognize it as an Inova or an Anova, because you have numbers sorted by categories. In this case, I have the GPA sorted into the 4 most popular majors. Does anybody need to see this one worked out? All right, Anova says, the question tells you that you have the institutional grade point average for the 4 most popular majors. It should say at GHC. Are the mean IGPAs for the 4 majors different at the 0.05 level of significance? Okay, so one of the things I notice in that statement, it uses the word different. Different, in my mind, implies they're not the same or they're not equal. So that this statement is the alternative. And this was another one where a lot of students were missing it. And I got to wondering if I had taught it wrong, because everybody kept missing it. But in this statement with the Anova, again, the idea here is this implies not equal or not the same because they're different. So we're saying the mean IGPAs for the 4 most popular majors are different. different, again, implies they are not the same or not equal. The null then would have to imply that they're equal. So we would say the mean IGPAs for the 4 most popular majors are the same. You could say are not different, but somehow or another you have to imply that they're equal, because the null hypothesis always and forever must contain equal. Then we have to find the F-test statistic and the p-value, which Minitab does. Okay, so I've got to take this data and move it over to Minitab, which is going to take me a minute to do. And you'll have the benefit of this being printed out on a paper copy that you'll be writing on during the exam, so you won't have to scribble them down like I'm having to do to transfer them. I should have printed off a copy, but I didn't. Okay, so I'm going to get a new worksheet. So again, I have a clean worksheet. And then I have to enter the data. So I have business administration, education, general studies, and nursing. And then I enter my data. Okay, so I've entered the data that was given to me. It's stat, Anova, one way. My data are in separate columns. I made 4 separate columns, and I have to choose all 4 columns. Click OK. Again, with Anova, we get lots of information. What I need is the analysis of variance. That's what I was running. I'm running the analysis of variance test. Okay. And so I get my results from Minitab, and on those results, it gives me my F test statistic and my p-value. So F is 3.25. The p-value is 0.040. I then have to make a decision by comparing P and alpha, the level of significance, which I was told in the problem is 0.05. So I'm going to compare my p-value to the level of significance. That process has not changed. So I have 0.040 compared to 0.05. You compare it digit for digit. 0 to 0, 4 to 5. 4 is less than 5. P is less than or equal to the level of significance. Whenever P is less than or equal to the level of significance, you reject the null. If I reject the null, that means the null is false and the alternative is true. So what I have proven in this particular problem, based on the data that I have, is that the mean IGPAs for the 4 different most popular majors at GHC are different. So I would write my conclusion, including the level of significance, at the 0.05 level of significance, the mean IGPAs of the 4 most popular majors at GHC are different. And there you go. And that's the last question. That's the last scenario grouping on the review for the final exam. Do you have other questions? Okay, let me remind you one last time before we go that the exam is Monday, December the 12th at 12:30 in our usual classroom, which is C160. You will be using Minitab on the computer in the classroom. You will probably want to have a handheld calculator. You'll need a writing utensil, and you can have one 8.5 by 11 sheet of paper with notes on it, front and back. Okay. It will take a little while for the video to process, but once it's processed, I will post it, the link to the video in the announcement, so that if you want to go back and watch any part of this review, you can do that. We do not meet at all on Wednesday. Today is our last official class day. Final exams for the semester begin tomorrow. But I will be monitoring email, and I will have office hours in Zoom on Thursday from 1 o'clock to 3 o'clock. Should you need some help. Anything else? It'll probably be after 6 o'clock before I get the video posted, because as soon as we get off of this, I'm headed to a funeral. Okay, guys, I will see you next Monday.